All right, hello everyone, and welcome to this Masterclass Explainer. I'm your host, and today, well, I'm not just presenting a slideshow. I'm talking to you as a UPW engineer with over 20 years of dirt under the fingernails experience on the plant floor. I've seen it all, and I know exactly what separates the pros from the rookies when everything goes wrong. Today, we're diving into a really critical issue, one that can literally bring your entire facility to its knees. We are going to thoroughly break down how to troubleshoot EDI DC power degradation. To tackle this, we're going to follow a strict 6-part diagnostic roadmap. First, EDI technology in UPW. Second, recognizing DC power issues. Third, potential root causes. Fourth, isolating the root cause. Fifth, executing the fix. And finally, sixth, summary and key takeaways. Let's move through this systematically, because that's the only real way to fix critical infrastructure. Okay, part 1, EDI technology in UPW. So we start with raw water, right? We push it through the multimedia and cartridge filters to strip out the bulk particulates. From there, it hits the RO system. But step 4, that's where the magic really happens. And frankly, where the system is most sensitive, the EDI module. Think of it as your ultimate gatekeeper. Water has to pass through here, and then UV treatment for us to hit that pristine product water resistivity of greater than 15 megaohms. If your EDI falters, your water quality tanks immediately.
Now take a look at the physical workhorse itself, the IonPure CEDI module. I want you to think of the DC power supply attached to this thing as its heartbeat, literally. It uses electrical current to drive ions into dilute and concentrating compartments. If that electrical heartbeat skips or fails, the whole deionization process just collapses. You absolutely need that continuous, clean power to keep the bacteriostatic environment stable and do all the heavy lifting.
All right, part 2, recognizing DC power issues.
So, what are the symptoms? Well, a healthy DC supply gives you stable voltage, continuous power, and a super clean signal, just a nice flat line. But when it starts failing, you get this high electrical ripple. You're going to see unstable voltage, maybe some temporary short circuits or sudden power cuts. And I really got to emphasize the danger of that high ripple. Your EDI module expects a perfectly smooth electrical wave. When that wave gets jagged and chaotic, the internal dynamics of your module go completely haywire.
I want to pause right here, because as someone who has seen millions of dollars of equipment ruined, I need you to hear this warning loud and clear. If you ignore these failing power symptoms, you won't just get incomplete deionization and bad water quality. That fluctuating current and high ripple causes intense localized heating. It gets so hot it will physically melt the internal partitions of the module. No joke, you will permanently destroy the equipment from the inside out, leading to catastrophic downtime and massive replacement costs.
Let's move to part 3, potential root causes.
In my 20 years on the floor, bad DC power almost always comes down to one of 4 usual suspects. Suspect 1, an outdated rectifier. Aging components just lose their ability to turn AC power into smooth DC. Suspect 2, blown filter capacitors. These are literally designed to smooth out the electrical wave. When they blow, your ripple spikes. Suspect 3, a cooling failure. Power supplies generate heat, right? If your cooling fans or heat sinks fail, you get thermal instability. And suspect 4, nearby EMI. Sometimes it's not even your power supply, it's electromagnetic interference from new VFDs or heavy machinery bleeding electrical noise right into your lines.
Okay, part 4, isolating the root cause.
So, the golden question: how do we actually find the culprit? Put on your diagnostic hats. As engineers, we don't guess. We don't just blindly swap parts and cross our fingers. We follow a logical, verifiable process of elimination right out there on the plant floor. Here is exactly what you need to do. First, inspect the maintenance logs and the physical age of the rectifier unit. The history usually tells the story. Second, and please listen to me on this, put an oscilloscope on the DC feed. A regular multimeter will not cut it. You need an oscilloscope to physically see that ripple wave and confirm if your filter capacitors are toast. Third, check the power supply cabinet. Are the cooling fans spinning? Are the heat sinks choked with dust? And finally, walk the perimeter. Look for new installations of VFDs or heavy machinery near your runs that might be injecting EMI noise. Physical verification solves problems. Assumptions just lead to more downtime. Part 5. Executing the fix.
Now, before anyone even thinks about grabbing a wrench or screwdriver, here is a non-negotiable safety warning. The electrode wiring inside these module junction boxes runs at high voltage. It is a severe shock hazard. You must confirm that AC power is disconnected and completely locked out, following your standard lockout-tagout procedures. This isn't a suggestion, folks. It's how we stay alive on the plant floor.
Once you're completely locked out and safe, replacing the power supply requires absolute focus. Correct wiring demands using 12 AWG wire, verifying your anode positive and cathode negative connections, and making sure your local earth ground and cathode are at the same electrical potential. Do not mess this up. If you make a mistake and reverse the polarity, it's not a simple error you can just undo. Incorrect polarity causes immediate, permanent destruction of the module.
Here is your exact step-by-step recovery protocol. Step 1. Install a high-quality DC power supply that meets the exact current requirements of your module. Step 2, and this is the golden rule. Ensure the ripple of that new supply is less than 5%. Less than 5%, guys. Step 3. Secure your earth grounding and physically verify the cabinet cooling is functional. And Step 4. Establish a routine power maintenance schedule so you never have to operate blindly again.
Finally, Part 6, Summary and Key Takeaways.
Let's lock in the non-negotiable laws of EDI operation. 1. The DC supply is the absolute heartbeat of your EDI module. Respect it. 2. Understand the stakes. High ripple will literally melt your module's internal partitions. 3. Prioritize your life. Never, ever touch the inside of a junction box without verifying your lockout/tagout procedures. And 4. High-quality power demands, keeping that ripple below 5%.
I want to wrap up this explainer by throwing down a challenge to every facility manager and technician watching right now. Ask yourself honestly, when was the last time you actually put an oscilloscope on your feed and checked the DC ripple on your EDI modules? If you're hesitating or if you don't know the answer, your very next step should be reviewing your plant's logs. All right, thank you for joining me for this explainer. Stay safe out there, trust your instruments, and always verify.